Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Now, the success means not only the project success, but the engineer, that the site engineer, civil engineer, quality control engineer, how they will get success in their career. That also we are discussing in this channel. What is the strategy required to get success. So, what is today's topics? Today's topic is very fundamental about the steel reinforcement. All we know that we are using the ductile steel. Now, what is ductility of the steel? Why it is important, and what is the difference in between ductile steel and the normal steel? In today's video, I will discuss each and everything about this. So, stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. First things we need to know that what is ductility. In simple terms, ductility is a material ability to undergo significant permanent deformation, either in stretching or in the bending, under tensile stress before it finally breaks. Now, what is happening? If any material, if you are increasing load and on that, it will start stress will generating and the elongation will start. The point where it is finally breaks, that is called the ductility. Now, for reinforcement steel, it is the property that allows a bar to stretch physically after it has reached its yield point, providing a critical safety buffer for the structure. Because all we know in the concretes, very much good in the compression, but weak in the tension. That is why we are introducing steel to withstand that tensile stress. Now, what is the buffer? What is the limit for the tensile steel? That we need to know, and that is why this ductility is very much important. Ductility is typically quantified in two ways during a standard tensile test. Percentage elongation. Now, the total increase in length of the steel bar at the moment of fracture, expressed as a percentage of its original length, that is the measure of the ductility. And another measure is the reduction in area. The percentage decrease in the cross sectional layer of the bar at the point where it necks and breaks. So, these are the two things by which way you can measure the ductility of the steel, either in the percentage elongation, another is reduction in area, and another is elastic range also there, that I will come later. Now, what is the IS code? IS code is for the steel reinforcement is IS 1786 and IS 13920 for the ductile detailing of the reinforcement. Now we need to know about the stress strain curve, because from the stress strain curve itself we will understand what is the ductility, or what is the point, or where we can say what is the difference in between ductile steel and the normal steel. See, in the stress strain curve you can see the first is called the yield point, the point where the material begins to deform physically. For modern cold twisted or CMT bar, it's not often observed, that we all know. If clear or if you don't get the clear yield point, we are getting 0.245% proof stress. In IS 1786 also it is given 0.25% proof stress. So, the point where it start breaking, what is happening normally, if you increase the load, the stress will generate it, and if you release the load, it will come its original position. Say like a rubber, if you stretch it out, it will elongation will also happen, but if you release the load, it will come to its original position. But if you stretch it out more, it will start breaking. In the steel itself also, if you increase the load, it will increase the length and the tensile stress will generating, but if you release the load, it will come to its original position. But if you further increase the load, at some point it will start breaking. That is called the yield point. Then that point is called the elastic property of the steel, or the elastic range. And after yield point, if you increase the more, again it will without increasing the stress, stress will generating, and after some point it will break. That is the fracture point or the breaking point, and that is called the plastic limit, or the elastic limit and the plastic limit. And the yield point is the yield strength, the permanent failure or the breaking is happening, that is ultimate tensile strength. Both the properties are important for the ductility as well as the steel. Though what is this plastic plate was strain hardening? After yielding, the stress continues to elongate with little of no increase in stress, followed by a region where it regains strength hardening. Then ultimate tensile strength, I will discuss the maximum stress that bar can withstand before its fracture or its breaking. And what is the fracture point? Where the bar finally snaps. So, what do you understand? That one is yield point, and is ultimate tensile strength, and one is fracture. And another two parameter is also there. Why we need to know these two parameters also? In these two parameter is important to differentiate in between normal steel and the ductile steel. Total elongation is another term. The percentage increase in length at the point of fracture or the failure, the higher percentage increase, the higher ductility. So, at the point time any material will break. So, that point is what is the total elongation, that called the ductility, and Ts and Ys ratio. Ts is the total tensile strength and Ys is the yield strength. So, this is the ratio of tensile strength to yield strength. A higher ratio means the steel has a large reserve capacity between starting to bend and actually breaking. Now, what is happening? In the yield point, it started breaking, it will not come to its original position, and in the tensile strength point, the fracture point, it will permanently fail. Now, what is the ratio? When this from yield point to tensile point, if it is more, the elongation is more, that means the ductility is more, and it is less, then the ductility is less. In the normal steel, this Ts and Ys ratio is less, but the ductile steel, Ts and Ys is more, because the tensile strain of the ductiles is more than the normal steel of the same grade. If you are using 500 grade normal steel or the ductile steel, the ultimate tensile strain will be more for the ductile steel. Now, why this ductility is important? Why we are discussing today? Now, ductility is not just the material property; it is a line of safety requirement. So, what is that? Redistribution of stress. In continuation of beam or frames, ductile steel allows plastic hinge to form. This lets highly stressed section transfer their load to the understressed section. So, in the frame structure, it is distributing the stress, which is very much important, because if any point of structure, any point, if the load is coming, and if it is more than the load this can carry, in the ductile steel, it will transfer that load to in the frame structure. Now, the seismic resistance. The earthquake is a big problem for the structural safety or the structural stability. Now, to withstand the seismic strain, we are using the ductile steel. During an earthquake, structure absorb energy. So, ductile steel dissipate this energy through deformation, swaying rather than snapping. In the normal steel, it will break eventually, but the ductile steel, that is why the seismic resistance, that is why the IS code has developed for 13920 for the ductile detailing on to withstand the seismic resistance. Now, another important part is warning before failure. A brittle structure collapse instantly. Ductile structure develop large cracks and visible sagging, giving occupants time to vacate, and you can repair that one. But if it is not the ductile, suddenly it will break. So, it will a disaster. Now, the energy absorption. Why? The area under the stress strain curve represent the energy absorption capacity. Now, in the normal steel, the energy is less, the ductile steel, the energy is more. So, it can absorb the more energy. So, if it can absorb the more energy, what will happen? It will gives the strength to withstand the more tensile strength, and it is giving the structural safety or the structural stability of the structure. So, this is the 4 point, that is why the ductile steel is important. Now, why you need to, we have the ductile steel, we have the normal steel. Why the difference, and what is the difference as per IS 1786? See, you can say in the normal steel and the ductile steel, the where you do not need the seismic or the higher load, you can use the normal steel, but where the load is more and the earthquake prone area, that area you need to use the ductile steel without even thinking a second thought. So, that is why we have the normal steel also, and we have the ductile steel. So, where you need, you can use. What is the difference? I know 1786, it has the clear difference. It says first is the total elongation. Now, in the normal steel, elongation is 12%, but the ductile steel is 16%, 1/6. So, it is a higher tensile elongation. Now, why higher elongation is important? No, is this very much important to know that if you have the higher elongation property, why it is important. Now again, the energy absorption during an earthquake, a building is hit with massive kinetic energy. Higher elongation allows steel to stretch and absorb that energy, converting it to heat and a deformation rather than the breaking, giving the structure is more safety and the stability. So, that is why higher elongation property is important. Now, another visible warning, as I discussed, if a floor is overloaded, steel with high elongation will cause them beam to sag significantly. This distress signal allows people to see the danger and evacuate. Normal steel might snap within giving any warning, as I discussed earlier also. That is why the higher elongation is important. And then the structural integrity. In the collapse scenario, ductile steel stays connected even when twisted. This prevents collapse and where floors fall directly on top of each other, creating survival voids for the trapped occupants. But the ductile steel is not giving this scenario, and it is giving the structural stability. Now, the carbon percentage, this carbon percentage is also less in the normal ductile steel. Now, why the carbon percentage we are saying that because it is of the chemical property, and we need to know what is the chemical property. In the normal steel, the carbon percentage is higher and carbon percentage is lower in the ductile steel. Now, why we need the lower carbon? But first is the prevent brittleness. Now, higher carbon makes steel harder and stronger, but also more brittle like gas. So, it can stretch and come to its original position. If carbon is too high, the steel will snap suddenly under a heavy impact on earthquake. Lowering carbon ensures the steel remains soft enough to bend. So, higher carbon, it will break eventually without giving any warning, or it giving or not absorbing more energy. But in the lower carbon, it's like a soft or like a gas. It is bend whenever the earthquake is happening or the massive load is coming, and when it is removing, the load is not there, it is coming to its original position. Now, improves weldability, that is another criteria for the lower carbon. Carbon interfaces with the welding process. Steel with lower carbon content can be welded easily on site without creating weak, brittle spots at the joints. That is why in the site it is sometimes you need to make the welding. But if it is a higher carbon steel, it is difficult to make the welding in that. But it is a lower carbon, we can easily make the welding. So, that is why the weldability also required, and the ductile steel has the more weldability and better corrosion resistance. Now, steel is prone to corrosion. All we know, if it is inside the concrete, if it is carbon chloride ion and the carbon dioxide enter, and with the help of the moisture, it will start corrode. But if the carbon percentage is lower, what is happening? High carbon steels are often more susceptible to internal stresses that can accelerate, resulting in humid environment, which is ultimately start the corrosion of the steel. So, that is why the lower carbon is important for our ductility matter. And then TS and YS ratio. So, TS and YS ratio for the normal steel is 1.08 and ductile steel is 1.1 and above. And now, why the yield point is same for the old? So, that means yielding point is same, but the fracture point is more for the ductile steel. That is why ultimate tensile strength is more than the ductile normal steel. That is why the TS and YS ratio is more, because the tensile strength is more, and it gives that time to absorb the energy during the more earthquake or any heavy loads. And then impurity control also at a matter, that is higher limits of for sulfur and phosphorus is there in the normal steels, and the lower limit of sulfur and phosphorus make it still brittle. Again, it will just give in the structural safety. As we say that what is the application area of the normal steel, the general RCC structure, construction in non-seismic zone, but the high-rise building and the seismic zone 2, 3, 4 and 5, and where the seismic load is more, in that area we are using the duct. These are all about the ductility of the steel and what is the difference, and I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this, and I'm waiting for your valuable comments so that from your valuable comments everybody will be benefited. And thank you once again for watching me.